talked about quadratics a little bit when we were looking at polynomials. So when we were looking at polynomials, what did the word quadratic mean when it was a quadratic polynomial?
Squared.
It was squared. The biggest exponent was an exponent of 2. So every single one of the problems we're going to be looking at is going to have x squared in it, or some variable squared. So we also, when we were looking at factoring trinomials, we were specifically factoring quadratic trinomials. And so we already know what standard form is because we were looking at it when factoring. So for standard form, it is just ax squared plus bx plus c. Now, we will either use y equals for that or f of x. So all f of x just means it's just a function. F of x and y will be used interchangeably. Just depends on what the problem is. Sometimes we use one, sometimes we use the other, but they mean the same thing. Okay, so that is our standard form. For pretty much everything we do with quadratics, we have to be able to identify our a, b, and c. Our a is still what's in front of x squared. Our b is what's in front of x, and our c is the constant at the end. So whenever we graph a quadratic equation, it creates a U-shaped curve called a parabola. It is spelled like parabola. And it is exactly what it sounds like when it says U-shaped curve. It is a curve that looks like a U. Okay, that is what a parabola is. Now, we're going to look at the types of parabolas, at least the types that are functions. Okay, and this is where we're going to use the graphing calculator. We're not going to actually graph these today, but we are going to go ahead and talk about what the graphs look like, the properties of them, and the key features of them. So what I want us to do is I want us to grab your graphing calculator, and I want you to go to y equals and clear it out. Okay, once you are in y equals and you clear it out, this is the screen you should see. To clear, you just press clear. Now, we're going to input that first equation we have in the types of parabolas, where it's y equals x squared plus 2x minus 5. The y equals is already there, so we just have to put in x squared plus 2x minus 5. The big thing is you have to remember that you have to use this button here for your variables. It is what's next to the green button. It's green on nails too. Okay, then to graph it, you're just going to press the graph button, and it's going to show us what that looked like. Okay, so we are going to just sketch a rough picture of that graph. When our paper says sketch, that kind of implies it's going to be a little rough. It's not going to be perfect. Okay, so I want us to go ahead and just sketch roughly what that graph looks like for this first one here. You just sketch that in there. Then, okay, I want you to go ahead and graph the second one. So go y equals and clear it out, type in your new equation. The beginning of that starts with a negative, so make sure you use the negative key, not the minus key. So you to do it negative x squared plus 3x plus 7 so that you can graph that. And then sketch it on your paper.
Mine errors out.
Okay, there's a setting funny in there. Somebody turned plots on. If yours is erroring, let me know and I can check it. Because people turn random settings on. All right. Now, both of your graphs should look like this. So, what is the difference between the two?
One opens up, one opens down.
One opens up, one opens down. What do you think causes that difference?
Negative.
The negative in front. This one right here causes it to do what? Flip. We know that. That's what one of our transformations we talked about the whole time. If you put a negative in the very front, what does it cause to happen to our graph? Flip it. So if the a term, so what is our a term in the first one?
X squared.
It's not x squared, but it's 1. It's what's in front of x squared. Now, what's our b term? What's our b term? What is our c term? Okay, now let's do the same thing for the second one. What is our what is our a term?
Negative 1.
-1. What is our b term?
3.
What is our c? All right, so whenever we look at the a term, it will tell us immediately which way our graph opens. So if a is a positive number, so if it is greater than 0, okay, then the parabola opens up like a smile. Because when you're happy, you say positive things, and positive things make you smile. You can also say up like a cup because it rhymes. Okay, the other one is up like a cup. Okay, now when we have that, so that is us having our parabolas that open like that. Now, if a is negative, the parabola opens down like a frown.
Oh, that rhymes.
Because when you're sad and if people are being negative and mean, it makes you sad, so you frown. Okay, down like a frown. And that is when our parabola opens downward. Okay. Now, we have looked at a bunch of different types of functions at this point. Okay. And we have looked at one that has a couple similar properties to this one. So whenever we look at a quadratic, both sides of this graph happen at the same time, right? If we was to take our graph and fold it in half, both sides would match, right? That is very similar to how we had with absolute value functions. They were the same on both sides, okay? And if you recall, those had something called an axis of symmetry. Quadratics have that too. What does it mean to be symmetric? Same on both sides. So the axis of symmetry is just the line at which if you were to fold it, both sides would match. So we're going to write that out here. So the axis of symmetry is a vertical line that divides the parabola into two mirrored halves. Instead of the word mirrored, you can also say symmetric halves. So the axis of symmetry is essentially the middle line of a parabola. Now, to find that, we have to use our A and B. So there is a formula for that. And the formula for axis of symmetry is x is equal to negative b divided by 2a. We are going to use parentheses anytime we are plugging something in, okay? The reason for that is if you do not put your parentheses and then you try to type it into a calculator, it could be wrong, depending on the problem, okay? Because the calculator won't read it correctly. We have to use parentheses when we're plugging in, if you want to use your calculator especially. So this is essentially just the opposite sign of B over double A, okay? So when we're talking about axis of symmetry, you will often see me use an abbreviation for that as AOS. Just because I get really tired of writing the word symmetry over and over again. And we're going to actually go back up to those problems we just looked at, and we're going to find the axis of symmetry and talk about where they would be at on that graph. So if we go back up to this first question here, we have already found our A, B, and C. So in order to find our axis of symmetry, we're going to do x is equal to negative b over 2a. But what I'm going to do is I'm going to plug in the b and a from this equation. So what is our b from that equation? 2. So that gets plugged in to the numerator. What is our a in this equation? 1. So that's what gets plugged into the denominator. And then we just simplify that. So we have x is equal to, if we have a negative and a 2, what's going to be in our numerator? Negative 2. In our denominator, we have 2 times 1, which is, what is negative 2 divided by positive 2? Negative 1. So our axis of symmetry is that x equals negative 1. So this line here that cuts our parabola in half is x equals negative 1. That is our axis of symmetry. And that's how we find it. That's all we have to do to find it, is just plug it in to that formula. So we're going to do the same thing for that second example. Okay, so over here, let's also find our axis of symmetry. So we're going to do x is equal to negative b over 2a. What is our b we need to plug in for the second one? What is our a we need to plug in? So what's our numerator going to be? And our denominator? Now, a negative divided by a negative is a positive. And can we divide 3 over 2? Can we simplify it? So it's just going to be x is equal to 3 over 2. So this line that it cuts through over here is the line x is equal to 3 over 2. And that's how we find our axis of symmetry. Yes, ma'am. So from here, we're going to look at vertex. So with vertex, you have talked a lot about vertexes over the last couple years in math. When you're talking about angles, it's where the 2 lines connect to make the angle. In a triangle, it's where the 2 different sides connect. If you're looking at absolute value functions, it's where the v connects. Okay? All of those things have in common, they're all straight lines. It's where there's new lines coming from. This one is one continuous graph, but it's still kind of the same thing because it's looking where the direction changes. So if we look at this first graph, is it going up or down? Down, and then it switches to go up. So the vertex is the point at which it turns. It's where the turning point is of the graph. It's where it changes direction. So if I look at the second one, is it going up or down? What about now? Down. So right here is our vertex. So for vertex, we are going to put that it is the parabola's turning point. Because it's where it's changing direction. Now, if the vertex is at the lowest point, so like this first thing here, okay, this parabola here is at the lowest point. It's at the valley of the parabola. That makes it a minimum, okay? So if it's at the lowest point, it is a minimum. And that will only happen when it opens up like a cup, okay? But if the vertex is at the highest point, so if it's at the mountain top of the parabola, that is a maximum, okay? And that will occur whenever it opens down like a frown. So there is one word that has been repeated in everything here, and it is point. The vertex is a point, okay? So that means we have to find a coordinate pair. The x-coordinate of your vertex is just that x you found when you did the axis of symmetry. So it is that negative b over 2a. That is your x coordinate of your vertex every single time. Whatever the axis of symmetry is, that is your x. Now, if I have an equation and I have an x value, what can I do with that x value to find the y? Well, okay, let's think of it this way. If the cost of buying a shirt is 2x plus 1, and I said I'm going to buy 10 shirts, what would I do to figure out how much I was going to spend? I'm just going to multiply it by 10, or am I going to do what with that 10? Let's think. So if I have y equals 2x plus 1, and I know that x equals 10, what do I need to do to find y? Plug it in. Anytime you have an x value and you need to find the y value, all you have to do is plug it in. So here for the y value, we're just going to plug in x to find y. All we have to do is plug it in, okay? And we're going to do that with the first one, not with the second one, just because I don't want us to have to plug in a fraction today, okay? But we are going to do that with that first problem. So back up here, we are going to find our vertex, okay? So we're going to take our original equation, which is y is equal to x squared plus 2x minus 5, and we're going to plug in a value for x. So we're going to go ahead and set this up. Y equals x squared plus 2x minus 5. And what do I need to plug in for x? -1. That value we just found for our axis of symmetry is what we're plugging in. So if we look at this, what is -1 squared? 1. What is 2 times -1? Then we have minus 5. So what is 1 minus 2? What is -1 minus 5? So our vertex is the point -1, comma, -6. So that point right there is -1, comma, -6. So all we do is we plug it in, okay? When we plug it in, if you use parentheses appropriately, you can just type that into your calculator and it'll tell you what it is. But if it has negatives in it and you are not using parentheses, it will not give you the right answer, okay? So just be aware of that. You have to use parentheses when typing these into a calculator. So go ahead and get in the practice of writing them down with the parentheses like you need to type them in the calculator. But that is how we find it. So we're going to go ahead and do this example at the bottom. Okay, we're going to go through and we're going to find all the things. So we have number 1. So we have y equals x squared plus 8x plus 15. So we need to start by finding our a, b, and c. That should be step 1. So what is our a in this problem? 1. It's what's understood to be in front of x squared. Okay, what is our b? It's what's understood to be in front of x, or what is in front of x. What is our c? 15. So that is our step 1. That's always what we do for step 1. And what we can do from there is this graph going to open up or open down? Up. Why is it going to open up? Because it's, yep. So we can already make that statement. It's going to open up. All right. So we're going to calculate all the other things. So let's go on to axis of symmetry. So we're going to do x is equal to -b over 2a. Using this equation, what do I need to plug into the numerator? And what do I need to plug into the denominator? So what is our numerator going to be? -8 divided by, what is 2 times 1?
2.
What is negative 8 divided by 2?
-4.
So our axis of symmetry is x is equal to -4. And you have to put the x equals there because it's a line. Okay, you have to. Otherwise, you're not writing a line. Now, for our vertex, okay, once you find your axis of symmetry, you're going to go ahead and you're going to write out your x coordinate of your vertex. Because if you have your x coordinate, you have the first coordinate of your y, of your vertex, okay? All you have to do from here is plug into your original equation and find y. So we're going to plug into y is equal to x squared plus 8x plus 15. What do I need to plug in? -4. And again, if you use parentheses correctly, you can just type that into your calculator. What is -4 squared? Positive 16. What is 8 times -4? Then we have plus 15. What is 16 minus 32? What is -16 plus 15? So our y coordinate here is -1. And so that is everything we need to be able to sketch our graph, okay? So we already said this graph is going to open up. So it's going to open up. Our axis of symmetry is the line x equals -4. And our vertex is the point -4, comma, -1. That's all we have to do for that. Okay, so that is what we are looking at first today. Okay, and we're going to do some practice with that. So you all should have your pink paper still. And we're going to look at the first page of our pink paper. And when I say the first page, I mean the very, very first page. Okay? So, when we look at this paper, okay, the top part of this paper, this is all filling it in directly from your notes. I'm going to leave you to do that in just a second. Okay? There are 4 questions. We're going to go over 2 more of them together, and then I'm going to leave you the other 2 to do. Okay? So we're going to go ahead and we're going to look at question 7. And we're going to start by finding our A, B, and C. So what is our A term? -2. That is our A. That automatically tells me what? It's going to open down. Soon as we identify A, we know if this graph opens up or opens down. Okay, for our B, what is our B?
8.
It is 8. Okay, what is our C?
-5.
Okay, so we already know our A, B, and C, and we know that it opens down. So next we're going to move on to axis of symmetry. Okay, so for axis of symmetry, we know that x has to equal -b over 2a. What is my b value I need to plug in?
8.
What is my a value I need to plug in?
-2.
So once I do that, what is our numerator going to be?
-8.
Over, what's our denominator?
-4.
And what is -8 divided by -4?
2.
Okay, so our axis of symmetry is x equals 2. So I'm going to go ahead and put x equals 2 for axis of symmetry and make the x coordinate of my vertex 2. Then we are going to find our vertex. So to find the vertex, we take our original equation and we plug in our axis of symmetry. So we do y equals negative 2 times x squared plus 8x minus 5. And what do I need to plug in for the x's? 2. It's that x value we just found. Now, if you type that in to your calculator, just like it appears, it will give you the right answer. But if you don't have your parentheses right, it won't. Parentheses are very, very important, okay? The two most common problems with this is not putting parentheses in the right place and negative signs. And the negative signs really comes down to the parentheses part, like dropping negatives and everything because we don't have our parentheses there. Make sure you're putting those things there. Now, if I look at this part, do I square first or do I multiply first?
Square.
Square first. So 2 squared is?
4.
4 times negative 2 is? So we have negative 8 plus, what did I do wrong on that second part right there?
Put 2x.
Yeah, that's supposed to be what?
8 parentheses 2.
8 parentheses 2. What is 8 times 2? 16. And then we have minus 5. So what is negative 8 plus 16? It's 8. What is 8 minus 5? 3. So our coordinate is the point 2, 3. So that is our vertex. So we're going to go over here and put 2, 3. Now, did we say this opens up or down? Down. So it opens down. Okay. What is our axis of symmetry? Not just 2, but x equals 2. And our vertex is the point 2, 3. Okay. And that is how we set that up. Yes. Do you need to go too? You can go when she gets back. All right. Now we're going to look at number 8 together. Okay. For number 8, there's only 2 pieces to it. What is our A value for number 8? 1. Because understood to be in front there is 1. So that automatically tells us it opens up. Okay. What is our B value? Negative 2. Now, what is our C value? 0. Because there is nothing being added to the end. What is the numerical equivalent of nothing? 0. Okay, that's like having plus 0 at the end. We don't have to write plus 0, but that's what it's like having there. Now, we're going to start with our axis of symmetry. So to find the axis of symmetry, we do x is equal to negative b divided by 2a. What b value do I need to plug in?
Negative 2.
And what a value do I need to plug in?
1.
And then what's our numerator going to be?
2.
What's our denominator?
2.
What's 2 divided by 2?
1.
So our axis of symmetry is x equals 1. So we put that in our axis of symmetry. And we also put that as the x coordinate of our vertex.
What are they doing over there?
No idea. Just trying to figure it out though. Now we're going to find our vertex. To find the vertex, we plug our axis of symmetry into our original equation. So we have y is equal to x squared minus 2x. And what do I need to plug in for x? 1. What is 1 squared?
1.
What is negative 2 times 1? What is 1 minus 2? So our vertex is the point 1, negative 1. So we're going to go over here and add this in. Okay, does this open up or down? Now, what is our axis of symmetry?
1.
Not just 1, but
Comma 1.
x equals 1.
Oh.
Okay, for the axis of symmetry, we had to make it a line. And our vertex is the point 1, negative 1. There we go. So I want y'all to take the next 10 minutes or so. Fill in those first 5 questions and do the 2 last questions down here. Okay? You do not finish it during class. It is homework.
She was like the queen swing because she recommended you or something. Yeah, a few girls did. Christina did. She did. Someone else. Kylie did. Which one do you work at? The one that Christina works at on an airport.
Wait, you don't want to do 6? You do.
Yeah.
Yes.
Yep, you're going to finish the page. Thank you. The paper, you need a white one and a pink one. You get a number you feel like is too big, check the way it's typed into your calculator. Then check your negatives.
Ooh. I still feel like that.
Oh.
-3? She's talking about. No, he's talking about. Wait, so.
Oh, it only goes down. Yeah. Oh, wait.
Yes, ma'am.
Madison Colton Nichols.
Yes, ma'am.